Today's lesson is about the geometrical sequence. It's basically a revision of last year's work. The first thing that you need to, how do you identify a geometrical sequence? If you can get a constant ratio, you know immediately that it is a geometrical sequence. How do you get the ratio? You take the second term and you divide it by the first one, and that must be the same as the third term divided by the second one. Then you have your R, your ratio, and that means you have a geometrical sequence. And when you've identified your sequence, it's linear or arithmetic or geometric or whatever, then you know which formulas to use on that sequence. Okay. If you have a sequence like that, and you calculated your R, your ratio, always write in a circle which kind of sequence are you working with, geometrical. Now I quickly want to go through the terminology. The general term has a formula of Tn equals 8 times R to the power of n minus 1. The n is the number of terms. The A is your first term. R is your constant ratio when you divide it. And Tn is your nth term. Okay, I think that's all on your papers.
Yes, ma'am.
Yeah.
So, would say that you should show what type of sequence it is or pattern? Do we have to like mark it?
No, it's for yourself. Okay, another thing I want to quickly clear up here. Let's say that you calculated your general term and you got A is minus 3 and R is 3 to the power of n minus 1. Can you multiply these two bases with each other? Why not? Yeah, you have to look at the exponents. This one's exponent is 1. That one's exponent is n minus 1. And the bases also differ. This one is negative 3, that one is 3. The only way where you can multiply the bases is if the exponents are the same. Like for instance, you have 2 times n times 3 times n. Then you can multiply the bases because they have the same exponent. Then you can say it's 2 times 3 to the power of n. Right. So don't make this mistake. Don't multiply the bases. It's wrong. Let's look at our first example. It's on your notes. In this case, I give you negative 2, negative 4, negative 8, and the last term is negative 64. Now remember, if I give you a last term, that is also Tn. So Tn now has a value. You divide it, and you saw that it's a constant ratio, so therefore it's a geometrical sequence, and my R is constant, so it's 2. The first question is, how many terms are in the sequence? Now, you must always think of what they are asking. How many terms? So they actually want n. I have to work out n. You start with Tn equals negative 64. And then you write your formula for a geometrical sequence. Substitute everything as well as Tn's value. And then you divide by negative 2 to get rid of the negative 2. And now you get 32 equals 2 to the power of n minus 1. The 32, in fact, on your calculator and you get 2 to the power of 5. The bases are the same, therefore the exponents will be the same. And then you get n equals 6. Always answer the question, out of how many terms does this sequence exist? 6 terms. Okay. Second question. Determine the fifth term of the sequence. Think about what they are asking. What is T5? They already give you a clue. The 5 is the n. So my n is 5. Start with your general formula. Substitute everything in and remember, if you substitute the 5 in on the right hand side, you must also substitute it in on the left hand side. Some of you leave this as Tn, and then you will have a -1 for notation in your paper. Multiply everything out, and then you get T5's value, term 5's value. Any questions so far? This is old news. Now, what will happen if I give you an unknown sequence with variables? This is not on your notes. I tell you it's a geometrical sequence. The first term is p, the next one p plus 1, the next one p plus 2. And I ask you, what is the value of p? What is the outstanding characteristic of a geometrical sequence?
Constant ratio.
Constant ratio. So you use that and you say the second term divided by the first term must be equal, because it's a constant ratio, equal to the third term divided by the second term. And how do I get the answer? You cross multiply. So therefore you'll get p plus 1 times p plus 1 gives you a bracket squared. And p times p plus 2 gives you this. Okay, I'm not going to do the sum, I just thumbs up this to show you what you should do if you get a sequence with variables.
So, this is basically a find the in. You find that you might see you didn't put the strings into a U. So if this is not under the topic of algebra and the question paper, you don't have to show the LCD and strings now. Yeah. You can just go ahead and get your missing value.
Yeah. Okay. Any questions? Your homework for tomorrow is exercise 3, page 7, number 1 to 5.